The Flight Management Computer System, or FMCS, will be introduced in this module. We will start with a system overview. We will then discuss the Flight Management System interface. Lateral and vertical navigation will be covered as well. We will start with an overview of the Flight Management Computer System. The Flight Management Computer, or FMC, is the central component of the Flight Management System, or FMS. The other components of the FMS include the Autopilot Flight Director System, the Autothrottle System, the Inertial Reference System, the Global Positioning System, or GPS, and the Flight Management Computer System, or FMCS. The Flight Management Computer System, or FMCS, uses internal databases which contain navigation and aircraft performance information. This information is normally contained in your navigation charts and the aircraft performance manuals. The FMC also receives information from various aircraft systems such as fuel, pneumatics, air data, and navigation. The data from these databases and the various inputs are used to calculate optimum navigation and performance profiles. The navigation database includes data for all VOR, DME stations, and selected ILS, airports, and runways in your airline's operating area. The navigation database is updated on the same revision cycle as the printed navigation publications. Database updates are electronically uploaded by maintenance personnel. The data stored in the performance database includes such information as climb and cruise performance, maximum and optimum altitude information, drag characteristics, and maximum and minimum airspeed data for various configurations. Let's look at how the crew interacts with the flight management computer. The FMC communicates with the crew via a Control Display Unit, or CDU. The CDU is similar to a computer display and keyboard. FMC information is displayed on the CDU screen. Crew inputs data into the FMC using the keyboard. Two identical CDUs are located on the forward part of the center pedestal. The CDUs can function independently. One pilot can access FMC information while the other enters information into the FMC. In addition, each crew member can display different data screens on the respective CDU. The crew can also enter information simultaneously, although this is not a recommended procedure. We will now look at the FMC's lateral navigation capabilities. Flight plan information is entered into the FMC by way of the CDU. The information that is entered includes runways, departure procedures, waypoints, airways, arrival and approach procedures. The navigation database contains the latitude and longitude for each waypoint, VOR, intersection, airport, and NavAid. The crew enters flight plan information using the associated ICAO identifier. The FMC cross-references the entry to obtain the associated coordinates. If a point that does not exist in the database is entered in the flight plan, the FMC will automatically create a new waypoint. The FMC will prompt the pilot to define the new waypoint using coordinates or by defining the new waypoint in relation to an existing waypoint. Let's examine how the FMC computes a position. The FMC determines the aircraft's position by combining information received from the Inertial Reference System, the GPS system, and radio navigation beacons when available. The information from the NavAid is used to compute a position known as the radio position. This position is determined by using the navigation aid's coordinates and the information provided by the NavAid. DME information from separate DME stations is used to determine the aircraft's radio position. If only a VOR DME station is available, the FMC will compute the radio position using that station. DME stations as far away as 200 nautical miles can be used to compute the radio position. A single VOR DME station will be used if the aircraft is within 25 nautical miles of that station. The nav aids used for position computations can be tuned automatically by the FMC or manually by the crew. In either case, the FMC can use the information provided by the selected nav aid to compute the radio position. The computed radio position, the inertial position, and position information from the GPS are used to determine the aircraft's most probable position. This position is known as the FMC position. The FMC navigates based on this computed position. The FMC position is continuously updated and can be accessed by the crew using the CDU. Navigation between waypoints is based on the Great Circle route. This Great Circle route results in the shortest distance between 2 points on the Earth. Let's now look at the FMC's vertical navigation capabilities. The FMC uses the information stored in the performance database to determine the most economical profile for climb, cruise, and descent. Dispatch information is entered in the FMC during pre-flight. This information includes the cost index and the cruise altitude. The FMC uses the performance database and the information entered by the crew to compute the most economical speed and profile. Many companies use economical speeds with a cost index of 12 for all routes. The resulting descent speed is 252 knots independent of weight and ambient conditions. This can be modified according to company policy in order to suit ATC requirements. Climb and cruise should be left at economical speed. The FMC also computes the N1 limits for the various phases of flight. This speed and thrust information is then sent to the various flight instruments that serve as the target parameters for the flight. FMC profile information can be displayed on the CDU. The FMC will continuously monitor fuel quantity. Fuel reserve quantities are entered during the pre-flight. The FMC combines these two pieces of information to determine the estimated fuel at destination. In the event this value drops below the minimum fuel requirement, the FMC will alert the crew by displaying a message on the CDU. Together, the lateral and vertical navigation computations are displayed on the flight instruments to provide steering information to the pilots. Using the CDUs, the FMCs provide lateral and vertical navigation information which provide the pilots the information required to manually fly the aircraft along the computed path. FMC commands can also be coupled to the autopilot flight director system. The FMC links the autopilot, flight director, and auto throttles into an integrated flight management system. The FMC can provide direct commands to each system. The autopilot switches on the mode control panel are used to engage the lateral and vertical modes of navigation. The VNAV switch engages the vertical navigation mode, and the LNAV switch engages the lateral navigation mode. During integrated operations of the FMS, the FMC commands the autopilot and auto throttles to fly the aircraft on the optimum flight profile. In review, the flight management computer is the central component of the flight management system. Information from navigation and performance databases are combined to compute the most economical flight profile based on dispatch requirements entered during the pre-flight phase. The FMS can provide commands to the autopilot flight director and the auto throttle systems and fly the aircraft along the optimum profile. The crew interacts with the FMS using the CDU. The CDU is used to display FMC internal information and allows the pilots to enter parameters used to define the flight profile. This concludes the discussion on the flight management system.